Hello, fifth graders. This is Eureka Math. We are in Module 5. This is Lesson 14. And our objective today is to solve real-world problems involving areas of figures with fractional side lengths using visual models and/or equations. So, some story problems with area problems that are real-life situations. Okay, so let's go to our problem set. And please write your name on your paper. Number 1, George decided to paint a wall with 2 windows. Both windows are 3.5 by 4.5 rectangles. So 3.5 by 4.5 feet rectangles. Find the area the paint needs to cover. Okay. So he wants to paint the wall. He wants to paint a wall with 2 windows. Both windows, find the area the paint needs to cover. Okay, so the paint is going to cover everything but the windows, right? Because we want to be able to see out them. Those are curtains. Look out and you see the snow or the beach or the wherever you are, right? Okay, so if we want to paint the blue area and not paint the gray area, we need to figure out the area of the whole rectangle and then subtract 2 windows, okay? So I've just put in our length and width for the windows, and I'm going to create an equation right now, an expression that's going to tell us exactly what we're doing, so we can just follow it step by step. So first of all, the area of the big rectangle, and that would be length times width. So that would be 12 7/8 times 8 feet. Okay, that's the area of the big rectangle. And then we're going to want to subtract 2 windows. So whatever this area is, there's going to be 2 of them. So we can just multiply that by 2. Okay, and then the area of the windows is 4.5 times 3.5. Okay, so area of the big rectangle, area of the windows, and there's 2 windows. And that's going to equal the area that we want to paint. So let's get right to it. 12 7/8 times 8. So first I'm going to take 12 times 8. And then I'm going to add 7/8 times 8. Okay. So there I've taken that to the next step. And then I'm still going to subtract, and then I'm still going to multiply this whole thing. Okay. Then I'm going to take 4 times 3. And then 4 times 1/2. And then 1/2 times 3. And then 1/2 times 1/2. Okay. All right. Now I can take things to the next level. 12 times 8. What's 12 times 8? I am super tired, so I'm just going to use my calculator for that. It's such a simple little thing if you don't know your 12s. That is 96, okay? And then 7 times 8 is 56. Oops, it's 56. Over 8, okay? And then I still am multiplying the whole big thing here. 4 times 3 is 12. 4 times 1/2 is 2. 1/2 times 3 is 1.5. And 1/2 times 1/2 is 1/4. Okay? Now, let's take this to the next level. 8 goes into 56 how many times? 7 times. Okay? So I'm just going to cross that out, and I'm going to put the number 7 right there. 96 plus 7 is 103. Okay, subtract, and then 2 times 12 plus 2 is 14, plus 1 is 15, plus 1/2 plus 1/4. Okay, and 1/2 times 1/4, I need a common denominator there, so I'm going to change this 1/2 and I'm going to make that 2/4. So now I have 15 3/4. I don't need to put the and there. You know it's 15 3/4. And that number is getting multiplied by 2. So I'm definitely going to roll into the next page here, so I apologize for that. 2 times 15 is 30, and 2 times 3/4 is 6/4. So I have 103 minus 30 and 6/4, and I can turn this into 31 1/2. So 103 minus 31 1/2. But I think I'm going to put a fraction here so I can see more what I'm doing. So 102 2/2. Okay, do you see how that's the same number? Minus 31 1/2. So 102 minus 31 would be 71. And 2/2 minus 1/2 would be 1/2. Okay. It took a lot of work to get there, and you're going to have to write small because they don't give you a whole lot of space. But the paint is going to cover 71 1/2 feet squared. Okay, that's a 2. I wrote it a little fast. 2. Okay, squared. All right, so pause this if you need to pause it because I'm about to erase this so that I can write in the rest for number 2. But I will write the answer over here, 71 1/2 feet squared. Okay, pause now. Okay, number 2. Joe uses square tiles, some of which he cuts in half to make the figure below. If each square tile has a side length, so each of these tiles has and they're square, has a side length of 2 1/2, right? That means that this side and this side each have 2 1/2. What is the total area of the figurine? Okay, I want to show you guys something. If you cut a rectangle in half this way, diagonally, you have 2 triangles, right? So this plus this is going to equal 1. Ooh, wow, my button went a little crazy there. Ooh, it's still going a little crazy. Okay. So this plus this equal a whole rectangle. So I could cross this one off and I could draw it in over here. Do you see what I did? And I could do the same thing here. I could draw that one in and cross this one off. And then here, I can cross this one off and draw it in there, okay? So now I have how many full rectangles? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then 11, 12, 13. So there are 13 square tiles, okay? Which means Joe uses square tiles, some of which he cuts in half to make the figure below. If each square tile has a side length of 2 1/2 inches, what is the total area of the figure? So all we have to do is find the area of one of these rectangles, and then we can multiply that by 13 because we know that there's 13 altogether. So the area of one square is 2 1/2 times 2 1/2. Oh, there's like this security car that drives around my neighborhood with their sirens on sometimes, and I don't know what the purpose is. They're not scaring anyone, it's just annoying. But I don't know if you can hear it in the background, it's annoying me. Anyway, okay, so let's find the square tile, the area of the square tile. 2 times 2, you know what? I always use the distributive property, and I know some of you like the improper fractions, so let's do improper fractions with this one, okay? 2 times 2 is 4, plus 1 is 5. And 2 times 2 is 4, plus 1 is 5. So our area is 25 fourths, which would equal 6 1/4 inches squared. Now that is for one of those squares, but there are 13, so now we need to find the area of this is the area of the square. Now we're going to do the area of the figure, okay? And that's going to be 6 1/4 times 13. And we said there were 13 because there's 13 rectangles, and we crossed off those 3 and we drew them onto these 3 so that we can see that they're full rectangles, squares. Squares are rectangles, okay? So now I am going to go back to my distributive property. 6 times 13 plus 1/4 times 13, okay, equals, what does that equal? All right, I need my scratch paper because I'm not so good at this stuff late at night. So 6 times 3 is 18, 1. 6 times 1 is 6, plus 1 is 7. So there I've got 78 plus 13 fourths. And 13 fourths is just the same as 3 1/4, right? So now I have 78 plus 3, which would be 81, and 1/4 inches squared. And that is the area of my figure, the whole figure. Okay? Yeah, that one wasn't so hard. You just have to know that if you cut a square in half, you're going to get triangles, right? Especially if you cut it let me rephrase. If you cut a square diagonally, you will have 2 triangles, 1, 2. And the area of these triangles, each of those triangles is just going to be 1/2 of the area of the whole thing, because I just cut it in half, right? Okay, number 3. All-in-One Carpets, that's a company, is installing carpeting in 3 rooms. How many square feet of carpet are needed to carpet all 3 rooms? So we have to find the area of this space, the area of this space, and the area of this space. Now be careful, they've given us some little added extra numbers in here, and we're going to need those to figure out the length and the width of everything. So first of all, let's go room A. The length is 25 1/4. And the width here looks like it's 15 1/2. Okay, good. Room B, the length is 18 1/2. And the width, this one, is 19. And C is a little bit trickier. It's a little bit trickier. Here we've got that number, 16 3/4, but we don't have this number. So how are we going to find that? Okay, what they did give us, I'm going to switch colors so you can see a little bit better. What they did give us was 2 feet here, 2 1/4 feet here, and we have this distance from here to here, which is 25 1/4 feet. So what are we going to do? We're going to take that 25 1/4, this one, and we're going to cut off the ends. Okay, so whatever's left in the middle is going to be the distance between here and here. Okay, so 25 1/4 minus 2 feet, okay, and minus 2 1/4 feet. So in fact, I'm just going to say 25 1/4 minus 4 1/4 equals 21. So the distance between here and here is 21. How did I find that? Well, 2 plus 21 plus 2 1/4 equals 25 1/4. Okay, now that I have that, I can add that over here. Go back to blue. Now I know my length and my width of all those numbers, so that's 21. Okay, now I'm taking a deep breath because that's a lot of math we're about to do. Are you ready? Let's find the area of room A first. And I am going to use improper fractions. So 4 times 25 is 100 plus 1 is 101 over 4. Times 2 times 15 is 30 plus 1 is 31 over 2. Okay. And then here I'm going to get out my calculator again, just to save a little time because, you know, we're doing so much math. This is why we have our calculator, is to cut down on these little things, right? So 3,131 over 8, okay? And if I'm going to solve that even more, 31 divided by 8 is, no, that's not right. 31 divided by 8 is, well, okay. Let's do it over here. 3,131 divided by 8. So 8 goes into 31 3 times. 3 times 8 is 24. That's going to give me a leftover of 7. I'm going to bring down the 3. 8 will go into 73 9 times. 9 times 8 is 72. 73 minus 72 is 1. Bring down this one. And now I have 11. 8 goes into 11 one time. 1 times 8 is 8. And now I have 3 left, so that's 3 eighths, okay? 391, that's a big room. That's a big room. Okay, so, and that's feet squared, okay. Next one, 2 times 18 is 36, plus 1 is 37 halves. Times 19. So again, I'm going to multiply across. 37 times 19 equals 703 over 2, which equals 351 1/2. I can do that in my head. Can you do that in your head? I think you should be able to. And the last one, 4 times 16 is 64, plus 3 is 65, 66, 67. Fourths times 21. 67 times 21 equals 1,407 divided by 4. So I'm going to do that over here. I'm going to find a little spot. 1,407 divided by 4 is 3 is 12, and then 2, bring down the 0, and then I've got 5, 5 times 4 is 20, bring down that, bring down the 7, 4 goes into 7 one time, and 1 times 4 is 4, and 3 left over, okay? So now I have 351 3/4. Wow, room B and room C are almost the same size. And I guess if you look at the picture, they kind of look like they're really close. Now I'm going to add, and I am going to change colors again. I'm going to add this number, and this number. So I'm just going to do that up and down, okay? Do you see what I'm doing there? So I've got 391 3/8 plus 351 1/2 plus 351 3/4. Okay, I'm going to get my calculator out again. 391 plus 351 plus 351 equals 1,093 And then I've got 3/8, 1/2, and 3/4. So now I need to change those into common denominator. So I'm going to use eighths as my common denominator. So this is going to become 4/8, and this is going to become 6/8. So now I have 3 plus 4 is 7, plus 6 is 13/8. Okay. 13/8, but I need to simplify that a little bit more. And I'm going to make that into 1,094 and 5/8. And what is my label? Feet squared. That is a lot of carpet. That's a lot of carpet. Okay. I like wood floors myself. Maybe a nice laminate, something that's easy to clean. Something that doesn't cat hair in it. Although, if I had carpets, that would be nice on my feet. When I lived in northern Wisconsin, or when I lived in Wisconsin, it would get cold, and it was nice to have carpet when you wake up in the middle of the night to go to the bathroom. You're like, oh, carpet on my feet. Here it's all tile, which is fine too. Okay. Mr. Johnson needs to buy sod. Remember we said sod was like grass? The grass that you can roll out and buy in big sections for his front lawn, okay? So that's his cesspit in front of his house. If the lawn measures 36 2/3 feet by 45 1/6 feet, and 2/3, okay? I'm just gonna go ahead and put my area model right away. How many square feet of sod will he need? Okay, so calculator, these are big numbers. Go ahead. You have my permission. 36 times 45 equals 1,620. And 45 times 2/3, well, what's that going to be? Well, 45 times 2 would be 90, and 90 divided by 3 equals 30. Do you see how I got that number? I'll show you. 2/3 times 45 equals 90 over 3, which equals 30. Okay? You see how I got that number? I could do that in my head. I hope you guys can do that in your head too. All right, now 36 times 1/6. That's just 6, right? 36 times 1/6, 36 times 1 is 36. And then that 36 over 6 divided, so that would be 6, okay? And then finally, 2/3 times 1/6, which would be 2/18, or if you wanted to convert it right away, we could call that 1/9, or simplify it right away, 1/9, okay? How many square feet of sod will he need? Well, 1,620 plus 30 plus 6 plus 1/9. And actually, I'm going to erase that. I'm going to draw 0 and 1/9. So I can add in a row 6, 5, 6, 1, and 1/9. So 1,656 and 1/9 feet squared. Okay. If sod is only sold in whole square feet, how much will Mr. Johnson have to pay? Whole square feet. That means that this whole section needs to go all the way out to a whole square foot. I'm going to show you. Okay. All right. You can always cut it because it's grass, right? You just cut it. So the first 1,000 square feet would be 27 cents. So 1,000 times, and this is our number, 27 cents equals, you know how to do this, remember? Remember? You just move the decimals over. Okay, we get 270. Okay, so there's 2 decimals there. 27 times 1 is 27, and 1, and then 2 spots. So it goes, all right. Next one. Next 500 square feet is 22 cents. Okay. Well, what would that be? 22 times 5 is 11, and a 0 at the end, right? 1, 2. Yep, so we just moved that decimal point 1, 2. We just moved it 1, 2, and 5 times 22 is 11. Now, additional square feet after that is 19 cents, so they're giving you a deal. However, we have 156 and 1/9 left, but I'm not going to multiply that times 19 cents because they only sell it in whole square feet, so I have to round up. I can't round down. I have to round up, otherwise I'm not going to have enough to cover that last little bit. So 157 times 19, okay? I'm getting sloppy here. So I'll put this here. 157 times 19. And 157 times 19 cents is $29.83. And if you don't remember how to do that, and I'll put the cents here too. Let's do it together, okay? 157 times 19 cents. 9 times 7 is 63. Carry the 6. 9 times 5 is 45 plus 6. Is that right? Ooh. 45 plus 6. Yes, okay, 45. Yeah, I am getting tired. Ooh, I should not do this late at night. 45 plus 6 is 51. Carry the 5. 9 times 1 is 9. Plus 5 is 14. Okay, and then drop a 0. 1 times 7 is 7. 1 times 5 is 5. 1 times 1 is 1. And then I get 3, 8, 9, 2. And there are 2 spaces to the right of the decimal, so I'm going to count 1, 2. And that's how I did that. Do you remember how to multiply decimals? Okay, all of the things that we've been learning this year, we're finally putting them all into practice, right? We learned how to multiply fractions and add fractions and multiply decimals and add decimals. So now we're using all of those things we've learned to answer these real life sort of questions, okay? These are things that you might actually use in your life, I promise. Okay, especially if you buy a house someday, you're gonna have to do math all the time. All right, now we're gonna add those numbers. 0 plus 0 plus 3 is 3. 0 plus 0 plus 8 is 8. Decimal point. 0 plus 0 plus 9 is 9. 7 plus 1 is 8. Plus 2 is 9, 10. Carry the 1. 1 plus 2 is 3. Plus 1 is 4. So, how much will Mr. Johnson have to pay? $409.83. That is a lot of money to have a green grass. I might just plant seeds and water it every day, I think. It's a lot of money. Okay, number 5. Jennifer's class decides to make a quilt. Remember we were talking about quilts yesterday. Each of the 24 students will make a quilt square that is 8 inches on each side. Do you know I did this when I taught 6th grade in Milwaukee? And we made a quilt every year that I taught at that school, and we hung them in the hallways above the lockers. It was really cool. And each kid made their own quilt square, and then we sewed them all together, and that was a really fun project. I miss that school. We did a lot of cool stuff. Well, you know what? I just miss being around the kids, right? Because we're on the video screen all the time. We can't do fun stuff like this. Anyway, sorry, distracted. It's already getting to be a long video, so let's keep going. Jennifer's class decides to make a quilt. Each of the 24 students will make a quilt square that is 8 inches on each side. So they are squares, okay? 8 by 8 inches. When they sew the quilt together, every edge of each quilt square will lose 3/4 of an inch. And why will they lose that? Because you have to sew on the edges. You know what? I am going to show you. Hang on. here's my quilting stuff. This is going to be good. All right. So I have 3 different pieces of fabric here, and I cut them into rectangles. And I cut them at a certain length, but then when I sewed them together, I had to leave a seam on this side. Can you see where the seam is? So when I fold it, you can see that there's a seam. And your clothes have this too. On the insides of your clothes, you can see that seam. So that's how much they're losing for the seam. They're going to lose 3/4 of an inch for every square. And if they're sewing them all together, they're going to lose a lot, right? So if I sew this to this, I'm going to lose 3/4 on each side. Does that make sense? So this is a quilt that I never finished. Maybe I will someday. It has to do with my sewing machine not being the greatest. And it gets clogged and makes me unhappy, so then I just leave it. Okay, so if we have 24 students, let's say we're making quilt squares that, let's say 6 going this way and 4 going this way. 3, 4, 5, 6. Pretend those are squares, okay? So if we do, because there's 24 students, so 6 times 4 is 24. And each of these is 8 times 8, right? However, it's not 8 times 8 because they lost 3/4 of an inch on all sides when they sewed them together. And we're going to put a border around it, so we're going to lose 3/4 on the outside too. Okay, just so we know what we're talking about. And 8 minus 3/4 on this side and 3/4 on that side. What is the space going to be inside? So 8 minus, and I'm going to add those together, 3/4 plus 3/4 is 8 minus 6/4, which is the same as 8 minus 2 and 2/4, which is the same as 8 minus 2 1/2. And that would be 7 2/2 minus 2 1/2, right, would be 5 1/2. Okay? So after we cut off all these edges for sewing, right, because we have to do it this way too, the inside where the part you see, right, so the part you cut is this big, but then the part on the inside looks smaller, okay? So this is going to actually be 5 1/2 times 5 1/2, okay? So draw one way the squares could be arranged to make a rectangular quilt. So I did mine 6 times 4. Then find the perimeter of your arrangement, okay? So the perimeter is going to be 5 1/2 times 6. Okay, wait a minute. Let me draw this in a better way. I'm going to erase all that now that we have that information, okay? Just so I have more space. If I had the board at school, I would cover the entire board with information every single day. Trust me, I would. Okay, so if we have 6 going this way and 4 going this way, and each of the sides is 5 1/2, we're going to do the length is going to be 6 times 5 1/2, and the width is going to be 4 times 5 1/2. Okay, so 6 times 5 is 30. 6 times 1/2 is 6/2, which is 3. So now we've got 33. Okay, is that right? 6 times 5 is 30. 6 times 1/2 is 6/2. 6/2 simplified is 3. Okay. And the width is going to be 4 times 5 is 20. And 4 times 1/2 is 4 halves, which is 2. So that equals 22. Okay? After we cut off our 3/4 on every side of every piece, our new perimeter is going to be 33 by 22 and 22 by 33. So the formula for perimeter is length plus width, and you can write that in any order. So here we've got 33 plus 33 plus 22 plus 22. And that means that 33 plus 33 is 66 plus 44, which equals 110. So our perimeter is 110 inches. And it's not inches squared, it's not inches cubed, it's the length that goes all the way around the outside. Okay? All right. Find the area of the quilt. Well, we know our length, which is 33, and we know our width, which is 22. So area equals length times width, which is 33 times 22. So over here we've got 33 times 22. 2 times 3 is 6. 2 times 3 is 6. Drop a 0. 2 times 3 is 6. 2 times 3 is 6. 6, 12, 726 inches. And now it is squared because it's area. Okay, perimeter is just 111 inches, but area is 726 inches squared. Awesome. Yeah, this is a long lesson. Okay, lesson 14 homework is more story problems, and we'll go through them in class. Don't worry. Your exit ticket is just one question. Mr. Klimek made his wife a rectangular vegetable garden. Okay? And the width is 5 3/4, and the length is 9 4/5. What is the area of the garden? Oh my gosh, after all those big, heavy story problems, this one's going to be so easy. Okay, get the answer right. Don't forget to label. Thank you, and have a great day.